Hello, everybody. In our previous video, we learned about how to add and subtract the radicals when you have like terms. Like when you have 5x plus 3x, it becomes 5 plus 3 of the x, so which is 8x. So as long as you have a like term, you can combine by doing addition and subtraction. So if you have a 5 radical 2 plus 3 radical 2, because you have a both term has radical 2, so they become a like term. So you end up with the same procedure as if you have x. So you end up with 8 square root of 2 or 8 radical 2. In a subtraction, same thing. When you have, let's say, 7 radical 3 minus 3 radical 3, you have a like term again. So you end up with a 7 minus 3 radical 3, which is 4 radical 3. So when you have a like term, you can add or subtract them. So in this video lessons, that some of the addition and subtraction, they don't have a like term. It look like they don't have a like term, but when they simplify them, they might have the like terms. So be able to simplify the radicals if it's possible. That is very important procedure. So when you have square root of 50 plus square root of 8, the 50 and 8 doesn't look like they are like terms. But when you simplify them, so the way you simplify in radical is separate each term with perfect squared number or a factor of perfect squared number. So if I change square root of 50 as square root of 25 and 2, 25 is a perfect squared number. So you end up with that 5 radical 2. So square root of 50 has the same value as 5 radical 2. Same as radical 8. You can break them into factor of square root of 4 and square root of 2, or product of square root of 4 and square root of 2, because 4 times 2 is 8. And 4 is a perfect squared number, so you end up with a 2 radical 2. So even though square root of 50 plus square root of 8 doesn't look like they are like term, when they convert them into or simplify into radical 2, now you have a like term. So it is end up with 5 plus 2 square root of 2, which is 7 radical 2, or 7 square root of 2. So be able to simplify them is very important. Now another example is if you have a square root of 32 minus square root of 18. So 32 and 18 doesn't look like they have a like terms, but when you break that or factor them into 16 and 2 or 9 and 2, you become 16 and 9, so the perfect squared number. So you end up with a 4 radical 2 and 3 radical 2. Now you have a like terms. So 4 minus 3 radical 2 become 1 radical 2. We just write as a radical 2 as a final answer, like this. Okay? So again, when you have 5 on number 3, and this was the number 2. When you have a 5 radical 12 with a square root of 75, again, you break 12 into 4 and 3, and 75 as a 25 and square root of 3. So you end up with a 5, and 4 is a perfect square number. It's a 2 radical 3 and 5 radical 3. When you have a 5 and 2 next to each other, that means it's product, it's multiplication. So if you do not have any two numbers without any operator, it's always a multiplication. So you end up with a 10 square root of 3 with a 5 square root of 3. Now you have a like term. So it end up with a 15 square root of 3. So if there is a integer outside, if anything can break out as a integer, you just multiply that. That's what it is. So when you have 2 radical 48 minus 4 radical 27, 48 and 27 doesn't look like they are like term, but when they simplify them with a perfect square number, 48 is 16 times 3, and 27 is 9 times 3, and square root of 16 end up with 4. So it's a 2 with a 4 radical 3, and 2 with a 4 is 8. Okay, so 8 radical 3. And square root of 9 is same as 3. So 4 with a 3 radical 3. And 4 and 3 makes 12. It ends up with 12 radical 3. So 8 radical 3 minus 12 radical 3, because you have a like term as well as take a bigger number, bigger integer away from, which is 12 away from 8, you end up with a negative 4 radical 3. Now, in number 5, you have a 3 radical 5 minus square root of 4 divided by 5. That's the same as 3 radical 5 minus, you separate radical 4 divided by radical 5, but you do not allow to have a radical at the denominator, so you have to do something called rationalizing it. The way you rationalizing it is you somehow make a denominator as an integer. In this particular case, you multiply radical 5 both top and bottom to keep the equality. Then you end up with the 3 radical 5 with, on a numerator, become radical 4 times radical 5 is radical 20, or 2 radical 5 rather, because radical 4 is same as 2. So you end up with 2 radical 5 on the top. And denominator radical 5 times radical 5, or square root of 5 times square root of 5, end up with a 5. Because every time you multiply same number in the radical, they end up with a, as long as a is positive, okay, or bigger than equal to 0. So you end up with this. So you could have answer like this, or you can combine them because you have like term. This is like 3 minus 2/5 with the radical 5, right? If we just take a outside of the radical only. So 3 minus 2/5 is 2 and 3/5 and radical 5. So that becomes your final answer. Now, this is a little complex, but if you do that, it's a square root of 24x minus square root of 2x over 3. Now I will break them into square root of 24 with the square root of x, And this one has a square root of 2x over square root of 3. Now, if I simplify this, then 24 is 4 and 6, radical x. So I'm breaking a 24 with a perfect squared factor. And then second one, square root of 2x, I have to rationalize it because I cannot have the radical in the denominator. So if I do that, I get 2 radical 6 and x. So I combine as a 6x minus, fractional multiplication, the numerator become 2 times 3, 6x. And the bottom one is 3. So from here now, you have like terms. So you have 2 minus 1/3 with the square root of 6x. Okay? Because square root of 6x means like 1 square root of 6x, so outside is 1/3. So 2 minus 1/3 end up with 1 and 2/3 square root of 6x. So that becomes your final answer. So now you can do more exercise, like number 7. Now I want you to do some exercise from the exercise 2 and check your answer with the answer key at the bottom of this section, end of this section. Now, next section is next topic is multiplication of a radical expression. Previously, we learned addition and subtraction of radical expression. So you can add or subtract and combine them if you have like terms. In multiplication division, like term doesn't apply. Instead of that, you can combine them if you have a same index. So like number 1, if you have the same index with the A multiply with the same index with the B, you can put them into one roof, or vice versa, in both ways. So you can combine them, or you can separate them. And so example, if you have an nth root of square root of 3 times nth root of square root of 7, it ends up with nth root of radical 21. I shouldn't say square root anymore because you have an nth root now. So I should say just radicals. So nth root of radical 3 times nth root of radical 7 become nth root of 21. And if you have something outside, you can just multiply separately. So 2 and 3 is outside, then you can combine 2 and 3 and 6. And inside, as long as they have same index, 7 times 2 is 14. So, for example, if you have square root of 5 with the square root of 2, when there is no index, it's always 2. So you have the same index. So 5 and 2 inside, you can combine them, and you have a square root of 10. Now, number 2, if you have 3 radical 2 times 4 radical 3, now outside together and combine inside together. So you end up with 12 square root of 6. Now, number 3, if you have square root of 3x with the square root of 5y, because they have the same index, you can combine them, 3x, 5y, and combine the numbers together, 3 and 5 and x and y, and end up with a 15xy. Because whenever you have a number next to each other, it's a multiplication. Number 4, if you have a 3 radical 4x, multiply with a 2 radical 5y, you combine outside together and combine inside together. So end up with a 6 square root of 20xy. But the thing is, square root of 20 is, you can break them as perfect square as a factor. So you can come out from the radicals. So now if you do that, that 4 and 5 xy. So you end up with a 6 with a 2 square root of 5 xy, and 12 square root of 5 xy would be the final answer of a simplest form instead of a 6 square root of 20 xy. Now, if you leave your answer as 6 times square root of 20 xy, is that wrong? Well, it's not totally wrong, but that's not the final answer, because you might have to simplify them and add and subtract if you have a like term, and so on and so on. So when you have some radical that it can be expressed or simplified further, then you have to do that. Okay? So depending on your teacher, they might give you some partial credit, or they might not. Okay, and there is a reason you have to simplify if it's simplifiable. Okay, otherwise you are not going to pursue the next step. Okay, next one. Number 5, when you have square root of 3x or square root of 6x, put them inside, but 18 can break into 9 and 2, one of the perfect square number, so 9 come out as 3. And also x squared, if you have an even power, can come out as x, and only things left inside was 2, so your final answer become 3x square root of 2. Okay, so out of 18, 9 square root of 9 can come out as a 3. Out of x squared, it come out totally as x. Okay. Now the next one is, if you have 6a multiplied with a 4a, you end up with a 24aa. 24 can break into 4 and 6, and square root of 4 come out as a 2, and a squared come out as a. So you end up with 6. So I guess this was wrong. So your final answer should be 2a square root of 6, not 3. It's a boo-boo. So this was wrong. Okay. Now, next one is a little complicated, but I'm sure you can do that. When you have number 7, square root of 6a squared y squared multiplied by 4a squared x. Now, there are many ways of doing this, but one of the way is combine everything in one same roof, 6 and 4, a squared, xy squared. And it end up with 24 a fourth xy squared. Again, 24 is 4 and 6. Okay. So 4 can, I'm going to take it out, so I know, because it's come out as a 2. A fourth come out as a square, because the way you can come out with a square root, power inside of square root is divided by 2 if it's even number. And y square also come out as a y. And whatever left inside, it was 6 and x. So you end up with a 2a squared y and square root of 6x. So that's your final answer. So that's how you do the multiplication portion of radicals. Now I want you to do this exercise 3 and check your answer with the end of section. Now the previous one was multiplication of radicals in binomial format times binomial. Now this particular examples are binomial, monomial. Oh, I'm sorry. The previous one was monomial multiplied by monomial. This example is monomial, which means one term you multiply with binomial, which is two terms. So for example, let's say you have product of radical 2 times radical 5 plus radical 6. So you have one term multiplied by two terms. So whenever you have a monomial multiplied by binomial, what you do is you do a distribution. You distribute radical 2 with a radical 5 and plus radical 2 with a radical 6. So you end up with the radical 2 times radical 5, and operator is plus, and radical 2 times radical 6. So it will break into monomial multiplied by monomial terms. So that end up with a square root of 10, end up with 12. And then important thing is you have to look each term, see if we can simplify further. 10 do not have any common factor as perfect square number, so you write as it is. But square root of 12 can have a factor as perfect squared number. Like what? Like 4 and 3. So square root of 4 come out as a 2 radical 3. So that becomes your final answer with the simplified format. Now, number 2, another example, a little more complex example of a monomial multiplied by binomial. So 2 radical 3, you multiply with the binomial, which is 3 radical 5 with a 4 radical 6. So you distribute this. 2 radical 3 times 3 radical 5 plus 2 radical 3 times 4 radical 6. And now you have a one term multiplied by one term plus one term multiplied by one term, monomial multiplied by monomial. And when you multiply them, outside the one you put them together, inside the one you put them together. Again, outside the one you put them together, inside the one you put them together. So you end up with a 6 radical 15, 8 radical 18. Now you look into each radical value, see if you can break them into perfect squared number when you have indexes 2. The first one, you cannot break the radical 15 into perfect squared number format, but 18 does. 18 is 9 and 2, right? So you can break them, and you finally end up with 8 times 3 radical 2. So 6 radical 15 plus 24 radical 2 And you cannot combine them because they don't have a like term. So your final answer become that. Okay. Now you have one more example on number 3. Okay. After that, look at the examples and then do the exercise 4 and check your answer with the answer key at the end of this section. Now, previous examples were multiplying monomial by binomial, one term multiplied by two terms. This one, we are going to look at the multiplying radical binomial expression, binomial times binomial, which means two term multiplied by two terms. When you multiply two term by two term, like a plus b multiplied with a c plus d, you distribute with the first term and you distribute with the second term. We call this one as a FOIL, right? This order we call FOIL. First one with the first one with the second one with the first one, and second one with the second one in the other binomial. So we're going to apply same concept, foiling it. So radical 2 times radical 5 plus radical 2 times radical 6 plus, now it's the second term, radical 3 times radical 5 plus radical 3 times radical 6. And it ends up with the square root of 10, square root of 12, square root of 15, square root of 18. But as you know, 10 and 15 do not have any perfect square number as a factor, but 12 and 18 does. So if you break square root of 12 with a 4 and 3, and square root of 18 as 9 and 2, your final answer becomes square root of 10 plus 2 radical 3 plus square root of 15 plus 3 radical 2. And you cannot combine any one of those, so that becomes your final answer. So that's how you multiply binomial, multiply by binomials. It's almost same as like foiling it. Okay. So so let me stop at the at this point, and we're gonna do more exercise later on. Okay. Thanks for the listening. Thank you.